Hey everyone, it's Miss Gubrud, and today we are going to be considering two of my favorites, Mr. Potato Head people. So, why? Because we're on lesson 115, 1-15, and we're thinking about scale and other proportional situations. Now, when you think of the word scale, you might think of something that we weigh something on. Maybe a scale that you have in your bathroom that you weigh yourself on, maybe a scale that's in the grocery store that you weigh fruits or vegetables on. This is a different use of the word scale. This doesn't have anything to do with weight. It has to do with how big or small something is compared to either the original or compared to something else. So that's why I've got two Mr. Potato Heads here. Now, they're different. One's Darth Vader and one's Captain America, you can see. But they're both Mr. Potato Head, but they're quite different in size. So, what does that mean when I say they're different in size? Is only one part different, or are all the parts different? They have to all be different. Look at the eyes. Look at the size of the eyes. The eyes are different. Look at the size of the feet. Feet are different. Look at the size of the helmets. Helmets are definitely different. So when you are making something larger or smaller, you have to make all of it larger or smaller. You can't just change one part because otherwise the scale is wrong. It means the relationship between one part to the whole thing. So like if I left these eyes Captain America size, but used the Darth Vader size helmet, that wouldn't work. I have to change all of them. But how do I know how much? We're going to use a scale to scale something up or scale something down. Means you change them all by the same ratio relationship. We're coming back to ratios and proportions. Scale, in this case, when talking about how big or small something is, scale is about proportion. Now, I've got another example. I have two globes. You can see they're different sizes. Now, a globe, by its very nature, is a scaled item. Why is this a scaled item already? Because it's a model of the Earth. Now, I certainly can't hold the Earth in my hand, although that'd be cool if I did. But this is already a model of the Earth. Now, the cool thing about this globe is it actually tells me what the scale is. So I'm going to see if I can show you this. Let's see if you can see. Can you see that? Oh, you can see that. Look at that. So there's the word scale right there. It says the scale of this is 1, and then you see the colon, to 41,849,500. And then it interprets that for us. It tells us that 660 miles is every inch on this globe. So every single inch, if you find an inch, here's South America. If you find an inch in South America, that a distance is 660 miles. It's a long ways. It's cool that it tells us the scale. 1 to 41 million, 41.8 million. Because 1 inch on here equals 660 miles of the real Earth. Now, would that be different, bigger, or smaller for this tiny globe? What would 1 inch equal on this tiny globe? A lot more, right? Because this globe is much smaller. So an inch in South America would be, I don't know, maybe twice this much. I wish it told, but I kind of scoured this globe and it doesn't tell me on here, which is unfortunate because we wish we knew the scale on this one too. But we know it's much more than 660. It's probably almost twice as much because the globe is almost around, looks like it could be about twice as big or twice as small. That's the element, the ideas of scale, making something bigger or smaller, and how much bigger or smaller. And that brings us to page 43 in our book. So you should have 43 out. And take a look at the trains. These are model trains. And if you've ever played with trains, maybe think way back when you were super little, or maybe you have a little brother or sister or cousin or something like that who likes like Thomas the train. They're teeny tiny little trains. Well, guess what? Sometimes older people like to play with trains too. It's not just a little kid thing. And for older people, they have more exact replicas. And they actually try to make it exactly like the real thing, but just smaller. And they come in different sizes. So that's what this picture is telling us about. It says model trains are miniature versions of actual trains. The scale of the model is a ratio that compares the dimensions of the model train to the dimensions of the actual train that they're making. Now take a look at these trains. These are all the same type of train. They look exactly the same. They're just bigger or smaller. So G scale is the largest scale that they're talking about, and it's 1:25. We read that, remember, 1 to 25, and what that means is every 1 inch on this model scale is 25 inches on the actual thing. Look at all the way down to this Z scale. 1 inch on the Z scale equals is connected to 220 inches on the real train. So that's what that picture is showing. They all look the same. They all have the same parts, but they're scaled up, which means their parts are bigger compared to each other, or they're scaled down, which means their parts are smaller compared to each other. So train hobbyists use scale ratios and proportions to design layouts for their model trains. You can use scale ratios and proportions to find the dimensions of model train cars. So that's what we're doing. We're thinking of things that are bigger and smaller, not weight. It's actual size of the different pieces. So start with me on number 1. The Big Boy was a famous locomotive, and this is really true. It was really a famous locomotive built during the 1940s. The locomotive was about 132 feet long. About how long is an S scale model of a Big Boy locomotive? Now, we have to look up here and find the S scale. Here's the S scale. The S scale is 1 to 64. So it says use a hint, use 128 feet instead of 132 feet for our estimate. Okay, so they're making the change in the numbers to make it a little easier for us. So you might say, oh my goodness, Miss Gubrud, I have no idea how to start. That's what we're going to talk about, how to get started. First thing is we read and we think about what they're asking us. We read about it. We know about trains. We've seen trains. Everyone's seen trains. Now, we know that we're trying to do an S scale, so it's kind of a medium size of the train. And it tells us we want to use that was 128 feet, and we want to use this S scale. So now we have to say, what if I started writing down things I know? I'm going to put the book down. And let's start. We know we've been using factor puzzles, so we're going to start with a factor puzzle. It's also how we were going to write proportions, so just so you know. All right, so we're going to use 128 feet was how long it was. We haven't written anything down, so that means I can put 128 anywhere I want. So I'm just going to put it here. 128. Now, once I put that in there, I want to label that. What is that? What is that 128? It's the feet of the real thing, right? So I'm going to label that feet of the real one. Now let's see what it says to us. It says about how long is an S scale model. Remember the S scale was 1 to 64. What's the 1 and what's the 64? Pause and think a minute. All right. I hope you paused and thought about what scale means. It means 1 inch on the toy covers the same amount of the train as 64 inches on the real thing. So what that means is we need to have a category of the real locomotive, and we also need a category for the toy locomotive. We've got the real one and the toy one. Now, 128 feet is the size. So we're going to label this the real size. And we only have one label left. What have we not labeled yet? The scaled size. And remember, we're talking about an S scale. That's a specific scale. So the S scale size. Because we want to know how big, if we made it in an S scale size, how big would this real locomotive turn out to be? What would the toy be? So we've got to put in other information that we know. And the other thing we know is that 1 to 64. We know the toy has 1 inch for every 64 inches of the real one. So where are we going to put that? We're going to put it under the S scale size, and we got to make sure we match up whether it's the real or the toy. So we got to match them up here. So the 1 inch is the toy size, and the 64 inches is the real locomotive size. Now we've got a factor of the puzzle we know how to solve. You might be saying, holy cow, this 1 and a 64, that's tough, 128. We didn't solve any factor puzzles with those big of numbers. But you might also start to notice a relationship, and you might be thinking, why did they tell us to use 128 instead of the real 132? We could figure that out, and we will later this year. But why did they change the number for us? You might be noticing a relationship here between 128 and 64. Are you noticing a relationship there? I hope you are. 64 times something gives us 128. Yeah, I hope you noticed that that's twice as big. So this number, if we're going over here, if we multiply it by 2, it gives us 128. Remember, going way back to thinking about rates early on in the chapter, remember we said if something's going on in the middle between these two numbers, it's going on all up and down. All of those numbers have to change by that same factor. So if we say 64 times 2 is 128, that means 1 times 2 has to be whatever this number is. So if it's multiplying by 2 on the top, or you'd go the other way, you'd say 128 divided by 2 is 64. The same thing has to happen here. Something divided by 2 gives us 1. Yeah. The answer is 2. So the question said, how big will the locomotive be in S scale? And the answer is 2 inches. Now, S scale's pretty tiny, but that's how big it's going to be. And we figured that out because we know there's a relationship in there. We could have also said this. We could have done, I'm using a different color and show you a different way to do it. We could have also said 1 times something gets us to 64. 1 times what gets us to 64? Well, it's a 1, right? So it has to be times 64. And then we would have said this side. If we go there with times 64, we've got to do the same thing over here. Times 64. Some number times 64 gets us to 128. We know the answer is 2 because it's double. But if you didn't, you could go the other way. I'm going to take even one more color. Hey, maybe dark green, that might work. I could start here and say 64 divided by something gets me to 1. 64 divided by what gets me to 1? Well, anything divided by itself is always 1. So you could just say 64 divided by 64 is 1. And if you divide from this row to this row. You also have to divide from this row to this row. So 128 divided by 64 gets me to 2. There's lots of ways to solve these proportions. If you're doing the same thing on both sides or the same thing all up and down, you're probably going to get the right answer. And then you're going to ask yourself, does that make sense? If it's 1 to 64, 1 inch of a toy is 64, it equals 64 inches of the locomotive. If it was 2 inches, if the toy was 2 inches, would that give us 128 inches of locomotive? The answer is yes. So you know you're on your way. All right, to solve numbers 2 and 3, you're going to use that same process of thinking. You're even going to use this same setup. In fact, I erased the numbers and left the setup for you. We want the real item with the real size, the real item in the S scale size. We want the toy item in the real size and the toy item in the S scale size. Here's a pro tip. Please do this, just like they changed the number just a little bit to make it easier for us to solve. I'm doing that for you as well. So on number 2, use the number 160 rather than 159. On number 3, use the number 75 rather than the number 76. Now, when you turn to the next page, it's back to relating time and distance. So you're going to think right back to what we were learning when we were racing. Are you faster than a Marshall Elementary 6th grader, Marshall Elementary teacher? And you are going to be going right back to graphing. So it's a review and a practice on the next page. It's this scale stuff that's brand new and pretty tricky. Good luck. Remember, if you have questions, you can come and see me in office hours any day this week. See you later.